Okay, this video is for mixed nomenclature, and what that means is this worksheet has both ionic compounds and molecular compounds on there. Now, an ionic compound is when you have a cation, all right? So a cation followed with an anion, whereas a molecular compound is a nonmetal and a nonmetal. So you'll want the orange ion chart out to look up a few things and a periodic table. So anyway, if you have a periodic table, this is a crude drawing of it, but anyway, here's the metals are on this side, or the cations are metals, and the anions or nonmetals are on this side. Okay, I think I spelled anions wrong, but anyway, all right, now. So if you take a look at the first element in a formula, that's K, that is a metal. So that one is ionic. If you look up at P, that's a nonmetal, an anion. So that one is a molecular compound. So to tell if it's ionic, just check the first element in the formula. And if it's a nonmetal, like nitrogen, it's a molecular compound. If it's a metal, like mercury, it's an ionic compound. Now there is one exception, is when you have this ammonium NH4 cation, okay? So you would see if you look at the ion chart that ammonium is at the very top, that makes this one ionic. But in general, if the first element is a nonmetal, it's going to be a molecular compound. If the first element is a metal, like potassium, then it's ionic. All right? Okay, let's review some ionic formula writing. Okay, with ionic formula writing, you want to use the charges that you look up on an ion chart or you have memorized. So potassium is 1 plus, sulfate is a polyatomic ion. I always like to put them in parentheses to start with, and that's 2 negative. I look at the charges, and if they're not opposite but equal, I do the crisscross method. And then I just rewrite it, K2. Now look, there's only one SO4, so I don't need to keep the parentheses. All right, calcium hydroxide. So I write calcium, I look up the charge, 2 plus. Hydroxide is a polyatomic ion, so I'm going to put it in parentheses. I put the charge on the outside. If the charges aren't equal but opposite, I crisscross. And then I rewrite. I don't show the 1, but I have to keep the parentheses on the hydroxide because there's 2 of them. All right, copper 1 oxide. So I write copper, I go 1 plus. The Roman numeral 1 tells me it's the 1 plus. Oxide is 2 negative. If the charges aren't the same, I crisscross, and then I rewrite without showing the 1. Okay, now that's ionic when we use the crisscross method. Molecular, however, just uses prefixes, no crisscrossing. So you just write down the symbol of the first element, carbon, write down the symbol of the second one, tetra, or chloride is Cl, but tetra means 4. The prefixes tell you how many you need. Dinitrogen, that means 2. Trioxide, 3. Silicon, if there is no prefix, it means 1. Monoxide means 1, so SiO. Okay, that was a review of molecular formula writing. Now, let's go to the ionic naming. Okay, so we're going to use the orange chart and the tile method to name these, okay? So the first thing you're going to do is you're going to write down copper, and when you write down copper, you have to see if it needs a Roman numeral or not. And so what you would do is you would see that copper does need a Roman numeral, so you have to figure out the Roman numeral, and I like to use this rectangle tile method to figure it out. So you draw a rectangle, you cut it in half, and then you say, okay, I need 2 coppers, so there's 2 coppers in the formula, so I go copper, copper, and then there's a sulfate, only 1 sulfate over here. Now, you know that sulfate, if you look it up on the ion chart, it's -2. There's 2 coppers, so each copper added together, this copper plus this copper has to equal +2 total. So that means each copper has to be +1. So the formula for this one is copper, Roman numeral 1, sulfate. Okay, this one, iron and chloride. So you write down iron, and you would notice that it needs a Roman numeral. So you could make the tiles or the rectangle. Make a rectangle, cut it in half. You need 1 iron and 3 chlorides. Chloride, chloride, chloride. Now you can look up each chloride is -1, -1, -1. -1, -1, -1 gives you a total of -3. So, but there's only 1 iron that has to cancel out 3 negative charges. So that 1 iron must be +3. So it's iron Roman numeral 3 chloride. Okay, the next one is just the name of the cation followed by the name of the anion. That's how all these ionic ones go. So you look up Mg, and that's magnesium. You notice that there's no Roman numeral needed with that one, so you just got to say the name of the cation is magnesium, followed by the name of the anion, which is hydroxide. Okay, same thing with this one. You look up the name of zinc, yeah, it's zinc, okay? And you notice there's no Roman numeral required. And then the name of the negative ion, that's called nitrate. Notice I didn't use any prefixes whatsoever. I just said the cation name followed by the anion name. Sometimes you need to use a Roman numeral. Okay, molecular naming, you're always going to use prefixes, all right? And so when you use the prefixes, the rule is you always use a prefix, except when the first atom is 1, you skip it. So for example, SF6, I'm going to write down the name of the first element exactly like it's spelled on the periodic table, sulfur. Notice I skipped the prefix because you skip it when the first element's 1. And then the second element always gets a prefix no matter what. So sulfur, hexa, fluoride. Notice that the first element's always spelled exactly like it is on the periodic table. The second one always ends in ide. Okay, S2O4. So that's going to be disulfur. And then 4 is tetra oxide. Okay, SO. Okay, so S is sulfur. And then O, the second element, always gets a prefix no matter what. And 1 is monoxide, monoxide. Okay, N4O8. So that's going to be tetra nitrogen. See how I spelled it exactly like it's on the periodic table? And then octa oxide. I guess you could probably drop the A there, but whatever, that's good enough, okay? Okay, mixed formula writing. All right, so being mixed, what that means is that it could either have ionic or molecular in it. So the first thing you're going to do is figure out if it's ionic or molecular. So you look at the first thing and it's magnesium. That means that it is ionic. That means you have to use the crisscross method. So you'll go magnesium 2 plus, then you'll write acetate is C2H3O2. That's a polyatomic ion. I'm going to put it in parentheses with the charge on the outside. If the charges are not the same, I'm going to crisscross. And then I'm going to end up getting Mg don't write the 1, C2H3O2, parenthesis 2. Okay, trinitrogen hexafluoride. Okay, when you see these prefixes and stuff, you know that it's molecular. You just do what the prefixes say. Trinitrogen hexa is 6-fluoride. Okay, here's the hard one right here, tin carbonate, tin 4 carbonate. So because that's a metal, that's ionic. So you got to use the charges. So you're going to go Sn, Roman numeral 4 means 4 plus. The carbonate is CO3, 2 negative. Okay, so now you could crisscross 2, 4. However, ionic compounds are always written in the simplest ratio. 2 and 4 can be reduced to 1 to 2. Iron 3 sulfide. Iron's a metal, that makes it ionic. So we're going to crisscross. Fe3 plus sulfide is S2 minus. The charges aren't the same, so we'll crisscross. Rewrite without the charges. Okay, tetracarbon, decahydride. Okay, the prefixes and nonmetals, so you know it's going to be a molecular. Tetra means 4, so 4 carbons. Deca means 10. Hydride is hydrogen, C4H10. Carbon monoxide, okay, that's molecular, so you're going to do what the prefixes say. 1 carbon, 1 oxygen. Okay, mixed naming. Okay, first you're going to identify if it's ionic or molecular, then follow the rules. Okay, AlCl3, that's ionic. That means you're going to follow the ionic rules, which is the name of the cation, which is aluminum. And aluminum doesn't need a Roman numeral, so you don't have to worry about that. Chloride is the name of the negative ion. No prefixes. Okay, N2Br6 is a molecular compound. Now you got to use the prefixes. Dinitrogen. 6 is hexa, hexabromide. MnO2. Okay, Mn is a metal, that's ionic. So you're going to have to write manganese. And if you look up manganese, oh, it needs a Roman numeral. So you got to figure that out. So you can use the rectangle method here. I'm just going to do it over here because I'm kind of running out of room. All right, and so basically I have 1 Mn and I have 2 O's, O and O. Each O is minus 2, minus 2. So minus 2 is a total of minus 4. There's only one of these. It must be plus 4. So it's manganese, Roman numeral 4, oxide. Okay, xenon is a nonmetal, and so is fluoride. So this one's going to be molecular. So you would use the prefixes. However, when the first one is 1, you skip the prefixes. So xenon, tetra, fluoride. S2O7, that is a molecular compound. So you got to use the prefixes. Disulfur. Notice how I spelled the first one exactly like it's spelled in the periodic table, except the prefix. The second one always is going to end in "ide," and 7 is hepoxide. Cr2O3. Cr is a metal, so you're going to use ionic rules. So that's going to be chromium. And you would notice, oh, chromium needs a Roman numeral. So I'm going to draw my rectangle. And I'm going to make this 2 chromiums, Cr, 3 oxygens, O, O, O. Each oxygen is minus 2, minus 2, minus 2. So that's 2, 4, 6, negative 6. 2 things must add up to plus 6. What's 2 numbers that are the same that add up to positive 6? Plus 3. So each chromium has to be plus 3. So it's Roman numeral 3, and then oxide. Okay, silicon, that's a nonmetal, so that's going to be a molecular. So we're going to use the prefixes. Silicon dioxide. And the last one is Cu2O. Well, this is an ionic compound. And so you would write copper, and you would say, oh, copper needs a Roman numeral. So I got to look that up. So I'm going to draw my little chart here. And this is one where people tend to get wrong. I don't know. It's kind of tricky, I guess. Anyway, so you've got 2 coppers in the formula, copper, copper, and 1 oxygen. You know that oxygen is -2, so total for a total of -2. So each copper must be what number to add up to +2 total, but 2 of them have to add up to +2, so each is +1. +1 and +1. So it's copper Roman numeral 1 because the Roman numeral, remember, is the charge. Okay? And then oxide. Okay, that's it for this video. So I guess hopefully you're understanding it better.